So I have the distinct pleasure to introduce our keynote speaker for today, Rick Avila, someone I've known for over 20 years. I first met Rick at GE Global Research at a time when we were just beginning to explore volumetric imaging in CT. He was actually the head of AI at GE at the time. Those early efforts ultimately led to bringing volumetrics into clinical practice and licensing the product we had developed to General Electric. Even then, Rick stood out not only for his technical ability, but also for his ability to see fundamental problems that others were overlooking. And I think that brings us directly to why his talk today is so important. Right now, there's enormous enthusiasm around AI and medical imaging. Models are being developed, papers are being published, and performance metrics, especially things like AUCs, often look very impressive. But there is a critical assumption underlying all of this work that is almost never discussed, and that is that the images themselves are consistent, comparable, and reliable. That's an assumption. Rick has spent much of his career showing that this assumption is simply not true. From his early work in computer-aided detection at GE to his leadership in quantitative imaging and open source platforms like VTK and ITK, Rick has always focused on the integrity of data itself. Now, as CEO of Acumetra, he is addressing what may be the single biggest barrier to making AI clinically meaningful, the lack of standardization in image quality, in image acquisition and reconstruction. His work on calibration phantoms is not just a technical refinement. It is in many ways a prerequisite for AI to actually work in the real world. Because without calibration, AI performance can drift, degrade, even become misleading, and we may not realize it. I tell you, this finally took place, or for me, it kind of really began to understand it when it became obvious that you can actually get better quality images, better resolution, and the AI software that you're using will actually start to perform worse because the software is calibrated. So this is a major problem. And this is not just an engineering issue, it is a clinical issue, it is a scientific issue, and ultimately it is a patient care issue. What makes Rick uniquely qualified to speak on this is that he has been at the center of all of these domains, from foundational imaging science to algorithm development to building real-world systems that have to perform outside of controlled research environments. On a personal note, he is a great friend, an incredibly creative thinker, and one of the most persistent problem solvers I know. If we are serious about integrating AI into lung cancer screening and into medicine more broadly, then this is a conversation we must have. There is no one better to lead it. Please join me in welcoming Rick Avila.